We're now going to work on writing fractions as division problems, simplifying, and equivalent fractions. So 3 things. The relationship between division and fractions is quite simple. Division is the process of breaking apart whole objects into fractional or decimal parts. So whenever you divide, you are making fractions because you're dividing something into equal parts, and you're usually talking about how many of those parts are there. Have you ever noticed the way we write fractions is the same way we write division problems? In other words, 2 numbers separated by a horizontal or slashed line. Okay? The notional similarity isn't an accident. Look at the fraction 22 divided by 7. When you have 22 divided by 7, if you look at the division sign, it looks like a fraction problem. Numerator, denominator, vinculum. Okay? So you're saying numerator, denominator, numerator. Blah, blah, blah. Okay? When you have the little house, you have the same thing. You have the slash. When you have the slash, we have the slash. When we do it as a fraction, we put it up horizontal. Okay? So, looking at equivalent fractions. Equivalent fractions are basically fractions that take up the exact same space, even though they may have different denominators and numerators. If we take one whole thing, we can divide it in half, thirds, fourths, fifths, sixths, eighths, and so on and so forth. You are going to decide whether fractions are equivalent and talk about yes or no if they are or not. Would you hit the lights, Jack? I can't see the bottom. All right, so let's look at the fractions 7/8 and 5/6. Okay? If I have 7/8, 1, 2, 3, 4, 5, 6, 7, my line would go right here. This is 7/8. If I have 5/6, 1, 2, 3, 4, 5, 6, should those 2 fractions be equivalent? No, because 7/10, oh, it's 7/10. They don't have eighths. 7/10 takes up more spots than 5/6 when you're talking about a whole. Okay? What are some fractions up here that you would say are equivalent? Yep. 4/8. 1, 2, 3, 4, 4/8, and 3/6. Because they take up the exact same space of that right there. All right? What's another one that's equivalent to those 2? So this would be 3/6, 4/8. Another one that'd be equivalent. 1/2. Another one. Chloe, you don't have one? Oh. 2/4. All of those take up the exact same space, so they are equivalent. They are equal to each other. Why isn't there a third that's equivalent to it? Why don't we have the denominator 3?
Because it's the way it looks sort of like a pattern where every other, or it's sort of like a pattern where every this tell.
Okay. Yes.
Well,
Shh.
they don't have the other ones because all the rest their denominators are odd.
Okay, they're odd, and we are doing halves. But also, 2/3 is larger than a half, and 1/3 is smaller than. So there's no way we can find a half equivalency in there. 3/5 is larger, 2/5 is smaller than. So they cannot be equivalent. With this one, it happens to be they're all multiples of 2 because we are looking at halves. Okay? All right, so equivalent fractions. Some fractions may look different, but they're really the same. For example, 4/8, 2/4, and 1/2. They're all exactly the same. They have different numerators, they have different denominators, but they are equivalent. Okay? It is usually best to show an answer using simplest form. That is called simplifying or reducing the fraction. When it is in simplest form, it cannot be made, and when they say smaller, we don't mean literally tinier. Okay? You're using the smallest possible numerator and denominator to keep the fraction equivalent. So if I have 4/8, and this is where people sometimes get stuck. They say, oh, put it in simplest form, make it smaller. Well, if I'm going to make 4/8 equal to 1/2, am I making 4/8 smaller? No, it stays the same. It does not get smaller. My numbers, however, get smaller, and that's what they mean. Simplest form means you put it into the simplest numerator and denominator, so neither can be reduced anymore. Okay? Yeah. Okay, move like where? So, let's look at these two. Shh. Do the circles here show equivalent fractions? Why or not? Why not? What is the fraction of this one? 1/2, because there are two sections, one is shaded. What is the fraction of this one? 8 sections, 4 are shaded. Are they equivalent? Why are they equivalent? Evan, why are they equivalent?
Because they are colored at the same amount.
The exact same amount is shaded in both of them. Okay, so those two are equivalent.
You say the white.
You could do either. I mean, technically they say shaded is with color. What fraction of rectangle A is shaded? A.
2/3.
2/3. What fraction of rectangle B is shaded? 6/9. Are they equal? Yes. Well, as equal as you can get the presentation to do it. Okay? They are equal. Even though the numerators and the denominators are different, they are taking up the same amount of shaded spot on our whole. Yes?
I see a pattern, so what? So if you multiply 5 for P by 3, it's 9, and if you multiply 2 by 3, it's 6.
Yep, we're getting you're ahead of the game. That's what we're talking about next. Find equivalent fractions. Exactly what Cole just said. What you do to the top, you do to the bottom. So if you're finding an equivalent fraction of 3 times 5, you're going to multiply the top and the bottom by 2. You multiply the top by 2, you're doing 3 times 2. You're doing 5 times 2. That equals 6/10. So 3/5 equals 6/10. Same thing down here. Now, when we are doing equivalent fractions in class, and I'm asking you to find equivalent fractions, I do expect that you show me which factor you are multiplying it by. You can do that one of two ways. You could do 3/5 and do little times 2 equals 6/10. Or you can write it as 3/5, 3 times 2, 5 times 2, 6/10. I will not accept this as your work for finding an equivalent fraction. That can be what your answer looks like, but when we are doing any kind of equivalent fractions, I am expecting to see this. And the reason for that is, when we get into adding and subtracting them, you're going to want to remember what you did. Okay? All right, on your whiteboards, I want you to write an equivalent fraction for each of those. Now, sometimes what you're going to get is you are going to get a partial bit of the equivalent fraction. Okay? So in this case, they're saying 2/3 equals something over 12. Well, when we talked about what you do to the top, you do to the bottom, what could we do using that concept to figure out what we would do with this, Sam?
Well, I already know what it is, but...
I don't want to know what it is. I do too.
No, but it's, 3. You would figure out how many times 3 goes to 12.
Yes.
Use that product,
Factor.
factor, and use it up.
Right. Basically, what you're going to do is you know that 3 times something equals 12. Figure out what the something is. And we know that 3 times 4 equals 12. And then you use the concept of what you do to the bottom, you do to the top. So if they multiplied by 4 on the bottom, you would multiply by 4 on the top. So this would be an 8. That's how you find a missing part of the fraction, either a missing numerator or missing denominator. Okay? Let's reveal. It won't reveal. Okay? So you find the missing factor, and then you'll know what to do to the top, to the bottom. All right, do this one on your... So let's click to reveal. You could figure out that to get from the 6 in the numerator to the 3, they had to divide by 2. Therefore, you divide the denominator by 2, because what you do to the top You do to the bottom, and so it would be 3/5. This is simplifying or reducing. Whenever you're simplifying or reducing, it is division, and you're simplifying and reducing down to the point where there are no more common factors. None. You're trying to find it, because does 3 and 5, if we had 3, what are the factors of 3? It's prime. None. 5? None. So do I have a greatest common factor between the two?
Yes.
No. So they are both prime. They cannot be divided any smaller. Okay? 1, you don't count 1, because if I divided the top and bottom by 1, I'd end up with the same number. Okay? All right.